Hi, welcome to our next level 1 geometry video. In this video, we're going to talk about a rule where angles are on the same arc. Alright, well you need to know that angles on the same arc are equal. Let's explain what we mean by this same arc and what we mean by them being equal. So we've got a circle. Let's introduce a couple of chords. Now the first chord starts at this point and heads up to this part up here of the circle. And then another chord starts here and heads down to this point here. So there's two chords. Now let's introduce two more chords. They start at the same point as the first two. So this first chord went up here and back down here. This next set of chords start in the same place, head up to a new point, but finish at the same place as the second other pair of chords finish. So hopefully you can see that we've got these two chords here that start and end at a certain point. And we've got these two chords that start and end at a point. They happen to be the same starting point and same finishing point. Now, if you can visualize that, then hopefully you can see what's about to happen. These two angles here are the same. These two angles are equal, because they are on the same arc, the arc that goes from this vertex across to this vertex. So these two, doesn't matter where I move it, you can see that these two angles remain the same. If I was to change the start point, the angles might change, but they stay the same. If I was to change my end point, again the angles will change, but they will remain the same. Now just be careful with this, because I don't have to pass through the center of the circle for this to work. Right, if you kind of visualize that, let's show you the other pair of angles, which are these two down here, because these are also angles on the same arc, this arc here. And you can see the vertex here moving around to the vertex here. So these two angles are on the same arc and are also equal. Now obviously the start point would be this point up here, and if I was to change the start point again, you'd see that the angles might change, but they'd stay the same. And if I was to change the end point, the angles stay the same throughout. So this is what we mean by angles on the same arc are equal. Right, let's show you an example and see if you can get your head around it. Example 1, find all the missing angles. So we have a circle here, the center is point O. We have a start point A, a chord up to AB, another chord down to BE, another chord that starts at A and goes up to D, and the second chord goes from D down to E. And F is where these chords intersect. All right, so we're going to find all the angles that we don't know. So let's start off with this angle up here, which is angle ABF. Well, ABF is going to be 40 degrees because angles are on the same arc. Now, what arc are you talking about? This arc here between B and D. So those are equal 40 degrees each. So angle ABF is 40 degrees. Now we're going to say the reason is angles on the same arc, or we could shorten it to angle same arc. Right, what about this angle down here? Well, these are also angles on the same arc. So angle DEF is 42, and it's this arc now we're talking about. So angle DEF is the same as angle FAB. They're both 42 degrees. Now, finally, let's turn our attention to the two angles in the middle. We know we've got two triangles created, and we know angles in a triangle add up to 180. So we just need to go 180 minus, let's look at one of the triangles, minus 40 minus 42, and each of these are 98 degrees each, because angles in a triangle sum up to 180. Right, thanks very much for watching.